Hey YouTube, welcome back to the shop and another BladesIIB project video. Got a customer project here today, so we may not get over to the lathe or the milling machine, so something a little bit different than normal. But that's what it's all about, getting out in the shop and getting some good project time. So before we jump into this project, just want to ask, if you like the videos, if you like the channel, please hit that subscribe button. I'm trying to get videos out on a weekly basis. Right now I'm shooting for 7 o'clock every Saturday morning, get a video out there. So that way you have a chance to check out what I've been doing in the shop while you're having your first cup of coffee for the weekend, and hopefully on your way out to your own shop to get out there to do something for your weekend projects. Today's project, with the freeze we had in Texas last week, unfortunately this customer's pool pump froze and it split the housing on this pump right now, so it is not making a seal and not able to pump and do what it's supposed to. It's, I think they told me the system on this is about 25, 30 years old. They are not able to find this part anywhere, and you know, you might be able to see that, but it's got just a hairline crack going all the way across there. So our goal is, we're not able to weld this. This is just made out of pot metal. So we're going to dig that out a little bit with a grinder, and then we're going to get in there and drop some epoxy in there, hopefully to fix that. If that does not work, I think option number 2 is maybe we could just make a flat plate to put on there to replace it. But this is domed. I'm not a pool pump engineer, so I can only assume it was domed and made this way for a reason. So we'll try and repair this one first and see what happens. The other piece, there's just a bolt. We'll find another 3/8 coarse brass bolt from a hardware store to take care of it. And then it looks like there's a gasket on here. It's so old and so hard, it almost feels like it's just part of the pot metal, but I'm pretty sure there is a rubber gasket in a groove of some kind. So we're going to try to dig that out a little bit, understand exactly what the gasket, whether it's an O-ring or some kind of just a square gasket in a groove. We'll try and get that taken care of so that ultimately we'll get this customer's pool back up and back in operation. So let's head over to the other bench and let's work on getting that rubber seal out of there, and then we'll get our grinder set up, and we're going to grind out that crack and get ready to drop some epoxy, some JB Weld in there to seal that up. Let's head on over to the bench. Alright, we've got this set up here. I'm going to put a face shield on before we use this Dremel, because it's going to be flinging stuff everywhere, so definitely want to make sure we have our right safety protection for that. And I think you should be able to get a better sense of where this crack is on here. Yeah, there we go. Get that in behind, and you can really see where this is split all the way across there. So we're going to get in there with the grinder and we're going to dig that out a little bit. And then we're going to drop our epoxy into that. So, I'm going to put some ear protection in. This is going to be a little bit loud. And let's get that cleaned up a little bit. I'm going to try first with just these sanding discs, see if that digs in there fast enough. I've also got a little carbide burr here. I've got some other ones we can pick from, but let's see how hard this is going to be to get this digging out a little bit. Okay, well, I am surprised. It is actually, I saw this brass over here on these edges, but I really thought that that was just from the screws that were going on top and maybe left a little color, but no, this thing is actually, this whole piece is made of brass. So, again, I could maybe try to braze that up, but I think we're going to stick with our epoxy plan for right now. But anyway, this is not made of pot metal, it is made of brass. I'm just going to turn that around, get some use out of the other side of that before we take it off. we have that dug out. I'm going to stick a little bit of just black tape on the backside. We're going to mix up some epoxy and we are going to fill that back in across there. Let's see, we got all the way out to the end of the crack over here, a little bit past over there. Yeah, we'll just cover that backside a little bit to give a little bit of something for our epoxy to push against, and we will get that filled in. Just using a little acetone, make sure we've got a nice clean surface there for our epoxy to get to. I prefer to do epoxy by weight instead of trying to measure it out by volume to make sure we get equal parts. So I'm going to put that on there first, and we will take our first part of our epoxy, and it looks like I've got 0.17 ounces of that one. We'll zero that out again, and we will go with and we ended up with 0.18, but I think that's still better than we would have measured if we were using it by eyeball. Get our epoxy thoroughly mixed. Scrape it all off the edges there. And I'm going to go find some gloves. And there we go. I want to make sure it doesn't drift off on our radius there. So I'm going to go grab the heat gun and we'll give that a little bit of cure just to make sure it's not going to go sliding off on us. I think we will just let that hang out and dry for the next 4 to 6 hours, and by tomorrow that should be ready to put back into operation. So a nice quick project in the shop today. After that's dry tomorrow, we'll come and play with that rubber gasket a little bit, see what we can dig out on the underside of that. But for right now, we're going to let that epoxy dry and we'll come back and check on it here in a little bit. Stay tuned. Well, it's been about 4 hours and just has a little bit of tackiness to it still. But the epoxy didn't run off the ends for us. Has a nice uniform thickness. I think that held up all right. Dropped in our groove nice. Let's take this tape off the inside and get some air onto, make sure that's able to dry from both sides. Take a look at how that turned out here on our inside. So that turned out looking pretty good in there too. You can see how that epoxy came out. The tape held it nice and smooth. It came all the way through our crack in all places, just a little bit off on that very edge right there where the epoxy didn't necessarily push through, but we know we dug in there, so we've got good penetration on that side. Same thing right over here. It didn't necessarily push the epoxy all the way through right on that edge, but same thing. We dug out. We've got good penetration over there. So that should be able to hold up and do all right. Now let's take a look at what we can figure out with this gasket, and we'll see if we can't pull this out of here. I want to make sure I don't squish into that epoxy too much, so grab in the right place. And let's see what's going on with this rubber gasket. Definitely a gasket there. Okay, so that is just a square gasket in there. We'll go get some measurements. We'll jump on Amazon, see if we can't find one. And it's just kind of a rough casting here on the back, but I guess that's just the way it is. Just this rough casting in there where the gasket was pushed into in a few places, but definitely very old and dried and cracked. So if we expect that to seal, we're going to need to get a new one of those on there. So let's see what we can find here. All right, let's take some measurements here and see what we've got. So to get a little more accurate, I'm going to hold the line over there. We're looking at 4 7/8 inside diameter, and we're looking at 5 3/8 outside diameter. So find a pen and some paper here. All right, so we're looking at 4 7/8 ID. And really more like 5 7/16 OD. Let's see how that compares with 4.8. 69, so that's within 1/6 thou of that. So I like my 4 7/8 there. So I think that's good. 5.432. Check our outside. All right, 5.433. 437 would be 7/16. So yep, I like that there. And that means we're looking at roughly a width on this of 0.286, 0.285, 0.286. So that's about 9/32. And depth, so thickness on this is about 196, 198. Anywhere upwards of 200 thou to 11. So 7. What do we get for a depth in here? Yeah, so about 196. So probably something like 7/32 thick. So somewhere around. Well, we'll leave that there to cure some more. Let's go see how we can make out on finding a replacement gasket. All right, I did a little reading on O-rings. All right, wanted to drop in a quick video here and just talk a little bit about how to measure O-rings. I had to do a little bit of reading on it. I hadn't measured an O-ring in quite a while, and way simpler than I was making it out to be. So to measure an O-ring, all you need to understand is the inside diameter of the O-ring. You need to understand the cross-section size of the O-ring, and the outside diameter equals the inside diameter plus 2 times the cross-section. So I was measuring the depth of the groove and everything else, and none of that matters in determining the size of the O-ring. I needed to measure our inside diameter and then needed to know the cross section, which in our case, definitely that O-ring was pretty squished this way. So pretty accurate reading across this way, or measuring the groove will give me that cross section, and that's how we can come up with the OD. And that was the same for round or square cut O-rings. So in our case, we had a 4 7/8 inside diameter, 4.875 plus 2 times that cross section. So 2 times 9/32 or 2 times 0.28125, and that is how we came up with the 5 7/16, so 5.4375 outside diameter. So we ended up getting there. Me measuring the depth of the groove, again, was not important. If you're trying to figure out the size of O-ring that you need, the depth of the groove, I looked online, and that's actually a whole lot of different engineering calculations based on the amount of pressure you want to put on something, the hardness of the material you're pushing into, whether it's up against a flat surface, whether it's a shaft inside of a bore. So there's a whole lot of of other determinations you need to calculate when you're trying to figure out exactly what depth to cut the groove for an O-ring. But in our case, the width of that groove gave us the cross section. We were able to measure the inside diameter, figured out what we were looking for, and also figured out that trying to find 9/32 O-rings online really was not able to do that. So 1/4 inch was the best I could find, and we'll talk a little bit more about that as we get back into the video. And I sure cannot find anything with a cross section of 9/32. So it looks like the closest O-ring for this one is going to be a 4 7/8 ID by 5 3/8 outside diameter, so a 1/4 inch cross section. That seems to be the only standard size. There doesn't seem to be anything else close to that. And also, it doesn't make any difference if it's a rectangular or square O-ring or if it's a round O-ring. Cross section is going to be the same. So ideally, we'll see if we can find a square cut one. But otherwise, on Amazon, I did find one that's a 1/4 inch cross section. I think that will definitely work to seal this back in place. So I think it'll work far better than this one by any means. So that's what I found for the customer, and I'm probably going to end up taking this back to the customer tomorrow, give her some part numbers of some things that she can order, and she's got a new cap coming for this. I verified the thread on that, so I did verify that this is 3/8 by 16, so just a standard bolt. She said she ordered a piece. It's actually a hand screw-on piece that goes on there, so we'll give her the dimensions on that and make sure that she ordered the right piece. But that should be it. We'll get this back to the customer. When I take it back over there tomorrow, I'll try and get a couple of pictures of the actual pump where this is going to go in place. But that's it. That is project complete right there. Customer's going to take care of the rest, and pretty straightforward to bolt it back onto the pool pump. All right, so here was that Anthony pump, and here is where that cover goes on that we repaired. So hopefully that's going to work for him. Well, YouTube, that wraps up another video here in the BladesIIB shop, as we just did a quick epoxy repair on this pool pump cover. As always, appreciate you watching, appreciate the comments you're putting in on these videos, and as I've said, if you have suggestions, ideas for another video, please drop that in the comment section. Happy to take a look at that. We'll be continuing to put videos out first thing on Saturday morning. So again, 7 o'clock Saturday morning, you're having that first cup of coffee before you get out in your shop to go work on your projects. Hey, you can take a look at what we've been doing in the BladesIIB shop in the previous week. So until next time, I hope you are out in the shop making some chips of your own, working on some projects of your own, and we'll see you soon. Take care.